A linear equation in two unknowns is an equation having two unknowns and the highest degree of both terms is 1. For example, you see is y is equal to 2x minus 1, and you will see that is power 1 for x, power 1 for y, and it is called linear equation. So you can write a lot of different equations like 2x plus y equal to 3, and then so you see power 1 and power 1 for x and y. We can't put them as product. For example, xy equal to 1 is not a linear equation. If you have square like y squared minus x plus 2 equals 0, it is also not a linear equation in two unknowns. So one of the reasons why we say it is a linear equation, because if we try to draw the graph out, for example, y is 2x minus 1, in the notes on the right hand side, you will see that when you draw this line out, it is a straight line. So it may be the reason why we call it linear. That means it's a line there. And then on the line, you will see that there are lots of different points. For example, in the picture, it marks you 2, 3. It also marks you 1, 1. In algebra, we can say that we can check the feature of 2, 3 when we substitute to this linear equation. When you put 2, 3 into the equation, you will see that your left-hand side is a y. That means it's a 3. Because you put 3 over there. While on the right hand side, when you substitute 2 as x, is 2 times 2 minus 1 is equal to 3. And you will see that if a point is on the straight line, the left hand side is equal to right hand side. You can also check the point 1, 1 as example. Now we try to check for one point which is not on the straight line. For example, the origin, which is called 0, 0. This point, it has another name, it's called origin as well. And if you try to put 0, 0 into this equation, you have the following result. Left hand side will be your y, that means it's a 0. Right hand side is equal to, putting x to be 0, you have 2 times 0 minus 1 is a minus 1. And you find that they are different to each other, which means the point itself is not on the straight line. Coming up next, we try to take a look in number 1, which you determine, that means you decide whether it's yes or no. It is a linear equation or not. Should be linear equation in two unknowns or not. For example, A definitely no, because you have only one unknown. When you simplify it, it's just 2x plus 2 equals 0. So that's why it's a no. C, you know whether it's correct or not. E, we explained a bit like a few minutes ago. D, it seems like a fraction, but if you read the question carefully and multiply 12, multiply 12, multiply 12 to each term, because I find that the denominators, the LCM of the denominators are 12. And when you multiply 12, you've got 4x. Multiply 12 to y over 4, you've got 3y. And 12 multiplied 1 over 2 is a 6. And you see it's also a linear equation. Next, we take a look in number 2, in which you are using a table to find solutions of the equation. Then you may wonder what was the meaning of solution in the equation. That means you are finding a pair of x and y which is fitting to the equation called y is 4x minus 1. And then, so how the table will be using will be the meaning of x is minus 1 here. That means you are putting x is minus 1 here. And then by calculator, y will be 4 times minus 1 is minus 5. So that's why the pair called minus 1 minus 5 is a solution of the equation. Similarly, you now put x to be 0, and you have y is 4 times 0 minus 1 is minus 1. So that's why you fill in minus 1 for the value of y, and we say 0 minus 1 is a solution to the equation. And the rest of the two numbers or two boxes, I leave it for you. And then another remark to you would be, for this pair, we have a name of it which is called ordered pair. Because it's a pair of number which is ordered, that means the first number referring to the value of x, while the second number refers to the value of y. Okay, that's number 2. And 2b, 2c, I left it for you. Next, we come to number 3, which is asking you about which order pairs, so you know this is called order pair, and satisfy the equation. That means it's talking about, you satisfy here means that you are talking about whether left hand side is your right hand side. So now we can do the substitution. Because we need not to have steps, so that's why I put 0, 0 into this equation. We just make a very quick rough work here. 2 times 0 is equal to minus 3 times 0 plus 7. On the left is a 0. On the right is a 7. So that's why it's wrong. Similarly, we check for 1, 1. 2 times 1 is equal to minus 3 times 1 plus 7. This is a 2, and this is a 4. So that's why it's wrong as well. And you may try C and D by yourselves. Next, when we come to number 4, is talking about whether the order pair solution of the equation. So we are doing similar thing by what we did in number 3 here. But the difference will be how you present the answer as follow, because you need steps this time. And then I will replace the sentence here by, I will put xy equal to, because you're checking the order pair called minus 2, 3 into the equation. And then that's why the left hand side becomes 2 times minus 2 plus y, that means it's a 3. Which gives you, 0. While on the right hand side is a 0, so that's why they are equal, satisfy, and also it comes to a solution of the equation. Okay, so we finished now up to number 4. 4b, I left it for you. And then number 5 is talking about a concept. Right now you know it's an equation. So it's something about substitution of x, substitution of y, etc. But now, how you can turn it into a graph. So it is the core concept that number 5 would like to bring to you. And the way we do will be, we are still using a table because we need some order pairs. And then, for example, like, rub away. Okay, for example, like here. When x is minus 4, you check is y is 1 over 2 times minus 4 plus 1. By calculator, you'll get minus 1. Okay, now take a minute to find out the value of y according to x is 0 and x is 2. So I give you a minute to do so. Time flies. And then, so please check your result. It should be 1 for the second value of y and 2 for the last one over the value of y. And then you do remember that in each pair we call it order pair. That means now we've got 3 pairs called minus 4, minus 1. We've got 0, 1, and 2, 2. We can call them order pairs. We can also call them solution of the equation. Okay, you have several meanings, several names of it. So we talk about order pairs, solution, and now come to the third way, or third understanding of it will be each of them. So you also have 3 points referring or talking about on the diagram. So as a result, if you want to draw the graph of the equation, so then you can plot the points now. Minus 4, minus 1. You have 0, 1. You have 2, 2. And then you can use a ruler, draw the graph. From x is minus 4, that means you're starting from this point. to x is 2, that means you end here, and then now you draw the line. Sorry, I don't have a ruler right now, so you use a ruler to draw the graph in a better way. And then last, don't forget to label the equation on the diagram accordingly. So is it easy? And then now we go back to check how you draw the graph as follows. Number 1, so you need to do the substitution 1, substitution 2, substitution 3. Next, each of the pair, we call order pair, referring to points on the diagram. And finally, you link up the points and label the diagram, label the graph. And that is. Okay, coming up next, number 6 will be more or less the same idea. But the one point we have to note will be it also recall your memory about how you make y to be the subject. It's one of the weakness of you, right? And then, so let's see how we are going to do so. When you want to make it as a subject, so first of all, you need to make y alone first. It's not putting it on the left hand side so quickly. So as a result, the first thing I will be removing will be 1 over 2. And next, we are going to remove 1 in our work. So that's why we have x minus 1 equal to 1 over 2 y plus 1. When you want to remove the 1 over 2, it goes to 2 times. We don't remove the plus 1 so quickly because I have something to expand on the left hand side first. So that's why we expand it. I have 2x minus 2 equal to y plus 1. And bear in mind that we want to leave y alone. So the next job will be we remove the plus 1. It goes to 2x minus, can you figure it out in a few seconds? Yes, it's minus 3. Afterward, you rewrite the sentence with y to be the subject, and then your y is 2x minus 3. The purpose of changing subject will be, do you prefer to write this one or the final one? And normally, if you rewrite the sentence to be this, like for this one, we have y to be the subject, and then you'll find that the sentence, the equation we are obtaining will be a bit clearer. Especially, you remember, the next job will be, we are asking you to do substitution on the table. So in this case, having a easier equation will be helping you to find the values of y, as well as drawing the diagram on the right hand side easily. So let's try it by yourself. Okay, next number 7 will be hard because it's checking your concept. Okay, so let's see what's happening. You have 2 order pairs and telling you that it's solution of the equation. And then the first thing you have to note will be, do you know the meaning of solution? Solution means that each of the order pairs can be substituted to the equation properly. What do I mean? I mean is, if you know it's a solution, that means you can put m3 into 3y minus 1 equal to x plus 2, where left hand side and right hand side are the same. You need not check it because the solution tells you it's true. As a result, your 3 times 3 minus 1 equal to m plus 2. On the left, it's just merely numbers, so that's why you can expand it by calculator. Sorry, not expand, you can just use calculator to find it. So it goes to m plus 2 is 6, or m is, I think you can do so, right? Okay, so if you got the concept, so recall it again. Solution means that you can do the substitution directly, and then you can have left hand side, right hand side are equal to each other, so that you can solve for an unknown. Now it goes to your work to talk about how you can manage minus 2n and relate it to the equation in order to find the value of n. Hopefully you can do so. I trust it. Okay, number 8 and number 9, it will be, okay, let's see. Okay, give me a minute to read the question first. Alright, now the question is talking about A is a point on the graph. So it's very like we talk about a solution we mentioned before. So that's why we think of substitution in one way, which is 1a can be substituted here. That means it goes to 2 times 1 plus a equal to 4. So that's why a is a 2. This is one way. The other way is I suddenly find that on the right there is a diagram given to me. So that's why 1a is a point on the graph. So 1 something is on the graph. So you have 1, 2 over there, right? So that's why we can read the answer directly. I don't suggest you to write so many words in the answer, and you can just simply write A is 2. That's finished. Or this is called method 1, which you read from the diagram. If you don't have a diagram, you need to use method 2, where a point, that means it's kind of solution, and you can do the substitution as follow. And then similarly, you have b minus 1. So you see minus 1 here, minus 1 here. So you can search for the point b, and probably you can read the value of b by yourselves, and I'll leave it for you. And then next, you have the c minus 1, 5 line on the diagram. And then we can check from the diagram, minus 1, 5 is here. And then so that's why we will say point C does not lie on the diagram, and that's why it does not satisfy the equation. It's not solution. So it seems like easy, but indeed the question itself tells you a lot of concept. It's talking about if it's not lying on the graph, it's not a solution. That's what the question wants to bring to you. So the chapter here will be a bit hard because you are moving back and forth from talking about graph, equation, solution, points of the diagram, etc. So let's see whether you can understand it quite well in the explanation as follow. Finally, we come to number 9. Let's highlight the keywords first. There's an equation, there's a point called A, and now when I read the point A, I know the y coordinate of it is minus 2, but this point, x coordinate, I don't know. So for my convenience, I will call a minus 2 as the coordinates of A. In part A, I'm asking you to find coordinates of A there. In other words, that means I need to find out what is more A first, so that I can look at the points clearly. As a result, how we are going to do it will be, first of all, I will let A be A minus 2. Because the letter A is not mentioned before, I need to let it first. Afterward, because it's a point on the graph, that means I can put A minus 2 into the equation 2x plus 3y equal to 6, where you know left hand side and right hand side are the same. If you forget the idea, please go back to question number 7 as another example. Okay, so I write. You can write also in your notes. So another reference would be, so question 7 in exercise 7a, and afterward you have 2a plus 3 times minus 2 equals 6. 2a minus 6 is 6. 2a is 12. That means a is 6. Is it the end of the question? Of course not. And then so as a result, you have to say coordinates of A, or simply you say A is 6 minus 2. And then so it finishes, well, we finish the question. And then afterward, in order to determine whether the point is on the graph or not, in this case, we have to check for left hand side, right hand side. I will take 7, so not 7, not take point B as example. Point B, 7 minus 1. Okay, sorry, let's wait. In this case, I will put 7 minus 1 into the equation. Sorry, I forget it. So what is it? 2x 3y 6 into 2x plus 3y equal to 6. Because you're asking yes or no, so that's why I need to check for left hand side, right hand side precisely. You have 2 and 7, 3 and minus 1. By calculator is 11. Or simply you can say it's not equal to right hand side. So that's why no. As left hand side and right hand side are not matching to each other, and then we say the point does not lie on the graph. I just simply say it does not. B2, I will leave it for you. Here's the end of exercise 7A. Hope it helps you to understand the things well.